Fine. So I think the screen is visible. Please respond if the screen is visible. Are you able to see
Uh,
the screen?
yes, visible.
Fine. Thank you. So good evening all. So welcome to the problem solving session of week 11 for the course Geotechnical Engineering 1, handled by Professor D.N. Singh of IIT Bombay. And I am Yogendra Narayanan. I am a PMRF research scholar who has been conducting these sessions every week. So to give a brief recap to the purpose of these sessions is that these sessions are intended to make the learners proficient in this subject by making them solve the problems based on the contents that has been covered in the particular week. Thereby, uh, it will be helpful for the learners to prepare for the NPTEL final exams as well as the competitive exams in their future professional careers as well to an extent. So today, to give a brief overview of the contents that has been covered in the previous week. So the concept of time dependent deformations as well as the compressibility of the soil, compressibility characteristics of the soils has been introduced, and the uh, terminologies are the properties which govern the compressibility of the soil has been discussed, as well as how to compute the immediate and final settlements. Uh, Consolidation settlements also have been covered in this particular week. So based on that, we will be solving some of the conceptual questions as well as some of the numerical problems uh, in this session. So let us go into the session now. So the first question: what all the factors affect the compressibility of the soil? What are all the factors that affect the compressibility of the soil mass? State of soil mass, type of loading, type of mineral present, all of the above. Any guesses or any idea based on the concepts that has been taught? What all the factors affect the compressibility of the soil mass? Any answers? Fine. So,
Sir, I think all of the above.
okay, fine. So now let us go by let us analyze each of the options. All right. So how we are coming to that conclusion? So first option is state of soil mass. So what does state of soil mass mean in this context? Any idea? What does state of soil mass mean in this context?
Saturated, unsaturated.
Yeah, this is one case. Another thing, another main important aspect. Fine. So as you mentioned, state of soil mass is uh, uh, obviously saturation, void ratio. Yes, yes, sir. E and water content. These are all the primary characteristics. Base main aspect is um, stress history, whether it is NC or OC. So that also that also comes under the state of soil mass. All right. So NC material will have different type of compressibility behaviors, and OC material will have different type of compressibility behaviors. All right. So that comes to that that these things cover the aspect of state of soil mass. So obviously these aspects govern the compressibility of the soils. So hence this option is right. And second is type of loading. Type of loading here essentially what does it mean? And what does type of loading govern? Any idea? So that is indirectly related to the first option also. So type of loading is that, so if you have a soil mass, so let this be the layer here. Type of loading need not be the load which is getting applied. So that is one type of loading. If you are applying an external load, let us say some sigma V, all right, or sigma A applied. All right. So already if you consider a compressibility of this layer, obviously it is going to compress more. And what about if we remove the load? So for example, you remove this. Let us consider a situation where the soil up to this level is excavated. All right. So in this situation, if you excavate the soil, so obviously the nature of the state of soil here will obviously convert itself from normally consolidated to over consolidated behavior. Hence, the type of loading essentially may be of two types broadly, which is increment of load as well as the decrement of load. So in that case, it affects the state of the soil, which in turn affects the compressibility aspects. So option B is also right. And option C is type of mineral present. Type of mineral present in the sense if it is a sand. So the expulsion of pore water, excess pore water will be instantaneous, right? So the settlement will be faster and the compressibility will be different because of its stiffness. And if you consider clay minerals, even in clay minerals, if you consider minerals, different minerals like kaolinite, montmorillonite, illite, halloysite, those minerals, their arrangement is different. Their even though the composition is of both silica sheets and alumina sheets, their type of arrangement is different. And between these layers, the double DDL, absorbed water, thickness of the absorbed water will be different. So these things entirely govern the compressibility aspects at a larger scale. But compressibility essentially is the macro phenomena that we observe outside. But the micro mechanics which governs these processes are micro level properties or properties of the grains, properties of the soil mass in the existing state are these three. State of soil mass, which includes saturation, White's ratio, water content, and type of loading, which determines NC or OC behavior, and type of minerals, which essentially governs the stiffness parameter as well as the amount of pore pressure that is going to be generated. So these, hence, all the three parameters govern the compressibility of the soil mass. So hence, option 4 is the right option. Any doubts or any clarifications which are required? Are you able to understand what I'm trying to convey?
It's fine, sir.
Yeah. So coming to the next question, compression of soil could be due to option A, expulsion of water, option B, expulsion of air, option C, reorientation of grains, option D, all of the above.
Sir, all of the above.
Why is it like that?
Yeah, because expulsion of water and air are the uh, natural primary condition for consolidation, and real orientation of grain uh, is this, especially in clay minerals.
Is expulsion of air related with consolidation?
Yes.
Expulsion of air is related to consolidation or compaction?
Oh, sorry, sir. Yeah, compaction.
Yeah. So even though the density increases in case of compaction, which indirectly is the which is due to expulsion of air. So in one aspect, it is a compressibility behavior, and option A, expulsion of water, is obviously it is time dependent, which is consolidation phenomena. Reorientation of grains can occur in two cases. One is immediate settlement in sands, which is due to sudden up when the moment you apply the loads, the grains get reoriented. And second possibility of compression due to reorientation of grains is during secondary consolidation, which occurs essentially uh, which is the primary characteristics of secondary consolidation, which is reorientation of grains, as well as if you have some organic content which is getting decomposed. In those cases, the voids that are present will get changed, which in turn results in reorientation of the grains. All right. So the compression of the soil eventually could include all the three options. Any doubts?
Fine.
It's fine, right? So let us move to the next question. The radial strain in oedometer test with a ring diameter D is radial strain in the oedometer. You know what is oedometer, right? You have conducted consolidation tests before.
No, sir. Just read little about odometer test.
Okay, but you know what is oedometer, right?
Yeah, it's a kind of a ring used for consolidation.
Yeah.
Yeah.
So oedometer is a ring of around 2.5 centimeter thickness, ideally, and 6 centimeters in dia. All right. So within which the sample is compacted to the required density, and will be saturated, and further loads will be applied in a at several time steps. All right. So here they are asking is what type of property is studied by using odometer test.
It's a consolidation.
So how many dimensions? How many directions of consolidation you can study in this?
In one direction.
Which is vertical, right? Why not horizontal or radial?
Yeah, because I think it works on Tejagi's one-dimensional consolidation principle.
Yeah.
So in that only one direction load is
Why
applied.
why uh, So consolidation is that the change in thickness you are measuring, right? So it is in the vertical direction you are able to measure the change in thickness of the sample. However, the side, that is the radial, when you have the top view of this ring, you will have like this, where you will be placing the sample entirely, and vertically there is no rigidity for the sample to move. So hence the sample will be free to uh, deform in the vertical directions. However, the horizontal directions, the boundary conditions are rigid, right? Even when you apply the load, the soil mass tends to uh, deform in the radial direction also. So that is the primary behavior of the soil. But the rigid boundary of the ring, oedometer ring, prevents it from moving in the radial direction, and hence the strain in the radial strain will be how much? So what does radial strain mean? So the vertical strain is delta H by H. If this is H, this is vertical strain. Radial strain is change in diameter by the original diameter, right? So is there any way for the diameter to change for the applied load and the soil mass? So since the wall of the that is the rings are rigid, this there will be no change. Delta D will be 0, and hence the radial strain will be 0 in case of oedometer. All right. So radial strain will is 0. 0. Are you able to understand? It's fine.
Yes, sir.
Yeah. So now coming to the next question, the D is to H, that is the diameter is to height ratio, has been taken as 3 in the oedometer test, because what could be the reason? Any idea?
No idea, sir.
So, right, straight away you can what to say? You can remove this option 4. So it does not. So soil specific gravity is a material property which depends on the soil grain type of grains. So that does not depend on the nature of arrangement of the samples, or whatever tests you are going to do. It does not get changed uh, unless the mineralogy itself changes. So you can remove this option. So vertical stress is 3 times the horizontal stress. That these your horizontal stresses, that depends on the uh, ratio of sigma h to sigma v. So that always sigma h will be less than sigma v. So that too, it does not follow this, essentially this ratio. So those concepts will be studying a bit late. So obviously option B is neglected out. Sigma H in ideal cases will not be greater than sigma V. And also this 3 times is even though this statement is qualitatively correct but not quantitatively correct. So this is also wrong. This is also not a right option. So, and the primary reason for choosing these dimensions is the due to the application of loads, there will be pressure bulbs which will be getting developed, right? You will be aware. In previous week you would have studied. So there will be pressure bulbs which is getting developed, right? Similar to like this. So these pressure bulbs for this dimension, the entire pressure bulbs will be accommodated within this within the samples once this ratio is being followed. So that is the reason D to H ratio is taken as 3. Fine. So the right option is C. All right. Any doubts?
Fine, sir.
Okay. Now moving to the next question. If the pre-consolidation pressure is 50 kPa and the pressure acting at present, that is the existing pressure, is 45 kPa, then the soil is in which state? How will you decide this?
Sir, it is in over consolidation stage
Why?
because due to more pressure in the past, it has more consolidation, and now
Okay.
the is less.
Okay. How will you quantify this? How will you quantify over consolidation or normal consolidation? What is the number we use? What is the ratio we use? So it is defined as OCR, over consolidation ratio, which is past pressure by, that is this stress that has been experienced in the past, that is pre-consolidation pressure by uh, present pressure. So here it is 50 by 45, which is greater than 1, and hence it is over consolidated clay. So this is in OC state. Understood? Any doubts? So
Mm.
always try to quantify what you are what to say. Uh, we are trying to say that it is in over consolidated state or normal consolidated state, right? So always we tend to quantify it. So whenever you are uh, conversing in this subject, you try to quantify whatever you are seeing. Fine. So quantifying means that uh, how will you measure it, or what is the parameter which you use to measure. So that is how you should be concentrating. Fine. So coming to the next question, which holds not true, which does not, which is not a true statement for compaction and consolidation. Any guesses?
So I think option B is not true.
Option B.
B.
Okay. So obviously you are right. So, but let us go by option for the clarity. So dry unit weight increases in both processes. That is obviously true. Even though for compaction it need not be completely, but there is an increase in dry unit weight. So in consolidation, there is a change in voids ratio, which will be eventually reflected in change in dry density. So this option is right. Compaction is due to sustained loading, while consolidation is due to instantaneous loading. So this is exactly the opposite. Compaction is due to instantaneous loading or what to say, kneading action. All right, kneading or vibration, which is instantaneous, and consolidation is sustained loading. So this is not true. Third option is in compaction, the air is expelled while water is expelled out in consolidation. So this is also obviously true from the basic definitions of compaction and consolidation. And option D, in consolidation, soil mass is saturated. So the primary assumption or of the theory of consolidation itself is that the soil is saturated, and even and also in laboratory tests we prepare the soil samples and then we saturate it, and then only we try to uh, we start to apply loads. All right. So this option is also right. So obviously, as you said, the uh, false statement is option B. All right. So coming to the next question, the spring analogy states that pore water pressure will increase while the effective stress will decrease with time. That is, during consolidation, they are trying to they are meaning during consolidation. All right. Pore water pressure will decrease while the effective stress will increase with time. Pore water pressure will decrease while the total stress will increase. An increase in effective stress will decrease the total stress. Which of the options are right?
Sir, I am just guessing, but pore water pressure will decrease definitely. It will
Okay.
not. Yes.
What about stresses? What about effective and total stresses? Any idea about that?
No, sir.
Okay. So now let us come from what does spring analogy states. So spring analogy is that, so there is a container, the entire soil mass will be converted into a spring that is placed in a water column. All right. Now there will be an opening that is left here. So there will be a valve here, and it is like a piston with the valve. All right. Now there will be applying the load and the valve will be opened. So based on the stiffness of this spring, which is the property of the soil, so the pore water will be starting to dissipate. Obviously, what you actually mentioned is pore water pressure will decrease. So obviously option A is not right, and option D, other three options are open, right? Now the total stress which you apply is the interplay between sigma total is equal to sigma dash plus pore water pressure. The total stress is that the stress which you apply. So if you uh, the primary condition is that this load which you apply should remain sustained. That means its magnitude should not change. Hence, the total change in total stress will be 0. Alright? Change in total stress. Please listen carefully. It is change in total stress will be 0 during the process. And hence, this option is also wrong. And total stress changes, this also is not wrong. This also is not right. Alright? Now here, pore water pressure will decrease while the effective stress will increase with time. Now, this remains constant. This is starting to decrease, which will eventually get reflected in increase in effective stress. So when this starts decreasing, this will be taken over by effective stress, because while the pore water pressure starts to decrease, that is, the pore water is getting expelled. In that case, uh, the voids ratio is reducing, which eventually results in increase in grain to grain contact, and the stresses transferred through grain to grain contact is the effective stress, and hence the effective stress will increase with time as the consolidation progresses, while the pore water pressure will start to decrease, and hence option B is the right option. Any doubts?
Fine, sir.
Fine. So coming to the next question. When the primary consolidation process in a soil is complete, when a primary consolidation process in a soil is complete, then which of the options are right? Hydrostatic pressure will become 0, the excess pore water pressure will become 0, both the hydrostatic and excess pore water pressures will become 0, or the effective stress will become 0. When the primary consolidation process in a soil is complete, then which of the following is that is occurs? Hydrostatic pressure will become 0, excess pore water pressure will be 0, both hydrostatic and excess pore water pressure will be 0, but fourth option is the effective stress will become 0.
Sir, excess pore water pressure will become zero.
Yeah.
B.
So
Mm,
never. Now let us go by options. So obviously, what the answer you gave was obviously right. So here hydrostatic pressure is indirectly the pore water pressure. All right. Hydrostatic pressure is also called as pore water pressure. Here always in consolidation, the consolidation process, that is the primary consolidation process, will occur such that uh, the pore water which is being developed due to the application of external load, that only that will be expelled, not the entire pore water pressure will become. It is not that the entire pore water pressure will become 0. There will be some initial pore water pressure that has been existing before the application of load, that will remain there, but due to the application of load, there will be an excess pressure that will be developed, and based on the drainage conditions, that pore water will expel. So only the excess pore water pressure will become 0, and effective stress will never become 0. If it becomes 0, then the soil will lose its strength completely. So in consolidation process, the effective stress will never become 0, right? So obviously this is not the right option. Here both options are given, so this is not right. Obviously this is not right, and hence the right option is option B. The excess pore water pressure will become 0. All right. Any doubts?
No, sir.
Now coming to the next question. Which of the following soil types will exhibit minimum settlement upon loading? Which of the following soil types will exhibit minimum settlement upon loading? Option A, clayey silt. Option B, over consolidated clay stratum. Option C, sand clay stratum. Option D, normally consolidated clay stratum. Any guesses or any conclusions?
Sir, option B, over consolidated clay stratum.
Yeah. So obviously, uh, the presence of clay will enhance its settlement characteristics, and among the uh, nature of that is the state of the state of soil. All right. So in that case, NC material tends to possess a greater uh, compressibility and hence result in greater settlement. And obviously, the over consolidated clay stratum, if the unless the pressure crosses pre-consolidation pressure, it does not it undergoes very little settlement, and hence in fact it will obviously it is a the soil will start to rebound. So in this case, the right option will be over consolidated clay stratum, obviously. All right. So coming to the next question, Terzaghi's consolidation theory is applicable to one-dimensional consolidation test for which of the following option?
Sir, for a small load increment ratio.
Yeah. So the primary that is the assumptions of Terzaghi's theory is that, or the primary application area where Terzaghi's theory is applied is that the load increment will be small compared to the existing stress states. All right. So other for a load increment ratio of nearly 1, which is obviously uh, that is the double. Uh, it need not be nearly 1. Uh, that also depends on the amount of existing load also. So you cannot properly quantify that. In situations where there is no excess pore pressures, that does not solve the purpose of that does not bring into consolidation itself. So it is also not right. It is not. It is incomplete. For large load increments ratios, Terzaghi's theory is not applied. The one of the primary assumption is that the load increment ratios should be small. All right. So option A is right.
Excuse me, sir.
Yeah.
Is it mentioned in the assumptions of the Terzaghi's theory? First
No,
one?
no, it is not assumptions, direct assumptions. You will not find it in any textbooks as such.
Okay.
But usually the application tends to uh, how to put it in right words is that usually these compared to the existing stress states, the load increment will be very small. So that is uh, it is understood obviously. So that is the only, it does not fall under the primary assumptions as such.
Okay, that means it is mentioned in somewhere, only few textbooks, huh?
Yeah, it might be referred, maybe in his own textbook, there might be they might be mentioning it.
Okay,
So, but
so
it is not most of the textbooks don't include this as an assumption.
yeah, that's why I asked you, sir. Thank
Yeah.
you.
So coming to the next question, which of the following can lead to pre-consolidation of a clay layer? Which of the following can lead to pre-consolidation of a clay layer? Any option? Uh, any ideas?
Is it first one, sir?
There might be many options also, multiple option also. But desiccation obviously contributes to pre-consolidation.
Second and fourth, no, sir.
Why?
Uh,
Sir, my guess is for option second. Okay, because in withdrawal of a glacier, so uh,
is it
air
accumulation or withdrawal, sir? Which is correct?
chances of water to get way to come out from the clay. Otherwise, all other options are not seemingly right.
So what causes pre-consolidation? That is here what they are meaning is that lead to pre-consolidation is that what leads to uh, eventually what leads to the clay layer which to behave as pre-consolidated.
One example is accumulation of the ice.
Accumulation of ice, yeah. So
Second one is construction of the building, sir.
yeah,
Multi-story building.
yeah. But that is in that case, if let me give you a situation, we can create a discussion on this. So let me give you a clay layer. All right.
Yes, sir.
Now let us consider the two options which you both have mentioned. One is withdrawal of glacier and removal of consumption load. These two, but whatever you said was exact opposite of that, right? So the formation of glacier above this layer as well as the load due to construction, right? So in both cases, the applied load is increasing. Am I right or wrong? Am I clear?
Which case, sir? Accumulated load.
So, for example, if you there is a clay layer and glacier is formed over that.
Okay.
So in that case, load is going to increase.
Yes,
As
sir.
well as if you are constructing a building or something, obviously the load coming onto the soil is going to increase.
Yes, sir.
So in that case, uh, it does not mean uh, it contributes to pre-consolidation, right?
Why not, sir?
Am I right or wrong?
It is adding a load, na, sir.
It is
Past load.
adding a load which is contributing in a factor once the glacier melts. So the building up and the melting of glacier will once the glacier melts, the load applied to the load increment due to the formation of glacier, for example, is eventually contributing to the pre-consolidation of the clay for further application of loads, right?
Okay, sir. You just proceed. We'll try to see it.
See, let me explain it clearly. See, now this is a clay layer, right? So this is under a particular stress, or it is it has not undergone any. It is in a NC state for primary understanding. So NC state also, without external load we cannot determine the NC state. So while formation of glaciers, it undergoes some settlement, all right, and it behaves as a normally consolidated clay, all right.
Okay, sir.
Now, when you remove the glacier load, what happens? Or when you remove the construction load, what happens?
Pressure releases or reduced.
Pressure reduces. That means the clay layer has prior to that some there was no pre-consolidation which has occurred, and due to these two factors it is contributing to a pre-consolidation pressure which was not existing before that, all right. Am I clear now?
Yes, sir.
So in one way, as you rightly mentioned, these option 2 and 4, it contributes the opposite of it. The formation of glacier and the uh, presence of construction load leads to pre-consolidation, and desiccation and desiccation of upper layers. Uh, it is little out of context in this category, because if this is replaced with over consolidation, then this and this will be the right option. So pre-consolidation of a clay layer, the can lead to pre-consolidation is that, in my opinion, it will be option 3. Any doubts?
Still, there was small confusion, sir. The second and first one looks like opposite words, sir. One is
Yeah.
the
So
withdrawal of the glacier.
let me, since this question is creating confusions, so let me reframe this question as such. So let us consider this as over consolidation of clay layer, which can lead to over consolidation of the clay layer, all right.
Hmm.
Now in this case, desiccation, which is uh, when you when the clay get desiccated, what happens? The load application is reduced in a way, all right. So there will be cracks which are formed, so which will result in increased void ratio, as well as uh, how there will be a change in density also, all right. So this option will obviously lead to over consolidation, and withdrawal of glacier also leads to over consolidation. Rising of water table will in fact increase the stress. It will not decrease the stress. And option 4, removal of construction load, is also, we are removing the stress, which is in a way leads to over consolidation of the clay layer. Now is it clear? So actually there has been the question is a little in a confused state. So it was in, I think, the previous assignments there was a discrepancy in this. So let me look into this question otherwise. All right.
Okay, sir. Okay, sir.
Yeah. So coming to the next question, which among the following is correct with regards to NC and over consolidated soils?
Option D, sir.
Yeah. So OCR is less than 1 for OC soils is obviously not right. So OC soils, obviously OCR should be greater than 1. OCR for NC soils will be less than or equal to 1. So obviously option D.
For NC soil is
Yeah.
equal or less than also, sir?
Less than, ideally it is less than 1. So less than 1, we both we use the term under consolidated also.
That's why I have asked, sir.
Yeah.
Normally for NC, they mention many books as 1 equal to
1
1.
only. In this case, NC soils is usually OCR equal to 1. OCR less than 1 essentially means under consolidated soil.
Yes, sir. Yes, sir.
Yeah. But if you see, while we do the calculations by using this E versus log sigma dash, so and we use the CC and CS, right? So
Yes,
in
sir.
this case, we place the criteria that whether the applied stress, total applied stress is greater than pre-consolidation stress or less than pre-consolidation stress. That is the only assumption we take. The in most cases, very rare cases, we get the stresses are equal, right?
Yes, sir.
So that is where this confusion arises. So, but as far as fundamental definitions are considered, OCR less than 1 is termed as under consolidation, under consolidated soil.
Sir,
Yeah,
a small extension about this question.
yeah.
Why most of the textbooks they don't discuss about under consolidated soils? Because somewhere I read that this is only like a made up soils. Municipal
Yeah,
waste material which dumped is a normal example of under consolidated.
yeah.
But why there is no any wide ratio effective stress graph for this under consolidated?
So, wide ratio under consolidate, wide ratio versus log sigma, that is E log sigma curve will ideally look like similar to NC soils only.
But they didn't mention anywhere in any book under consolidated
That
soil.
is where this nomenclature, this what there is a Misa-Namar revolving around this. So NC ideally, not ideally. So commonly NC means the applied pressure is lesser than the pre-consolidation pressure.
Yes,
So
sir. Yes, sir.
that behavior is treated as 1, and above, that is over consolidated behavior, is treated as 1. So only there are 2 divisions, but the definitions speak otherwise. So that is the that is where this confusion arises.
They ignore actually even in a present professor lecturer also here
Yeah,
in professor video. When it comes to under consolidated soil, he mentioned the title. That's all.
yeah.
Immediately there is no any discussion about that.
Yeah, because the analysis eventually divides the soil into 2 types. That's all.
Okay, NCC and OCC.
Yeah.
Mhm.
So that is why this. But as far as terminology is considered, we are introducing another one. What to say? Extra, uh, one term extra.
Mhm.
So that is where this confusion arises.
Okay. Otherwise, settlements are much higher than other two, sir. Compared with the other two, under consolidated will have
Yeah.
very high
Settlement will
set.
be higher. Yeah.
Then why they neglect this one actually?
No. You see, here
Mm,
the ideally the analysis part, right?
mm.
So the problems which we solve or the behavior aspects which we considered, this situation occurs very rarely.
OCR, yeah, extreme case, sir.
This is one of the very rare cases. So
Yes,
the
sir.
analysis is either OCR is less than 1 or OCR greater than 1.
Mm.
So ideally the NC behavior which we speak is speaking
Most.
about this only.
Mhm.
So that is where, but the definition speaks otherwise. So the usual notation which we use is not the same. So that is why this confusion is getting confusion is arised. But the analysis part which we do in a way in common notion, that is in during this undergraduate studies, is either OCR less than 1 or OCR greater than 1.
Okay. Right, sir. Right, sir.
Sir. So coming to the next question, a soil when loaded from 100 kPa to 500 kPa, the voids ratio changed from 1.05 to 0.95. What is the compressibility index of the soil? What is the relation for compressibility index?
Change in the void ratio by log of higher stress by lower effective stress.
Yeah. So Cc is equal to delta sigma by log sigma 2 dash by sigma 1 dash. So here it will be 1.05 minus 0.95 divided by log of 500 by 100. This you can take this as log 5. This will come around 0.1, right? By log of 5. How much we are getting here?
Point 143, sir.
0.1 divided by yeah. So this is 0.143 unit.
No unit, sir.
Yeah. So this is a ratio which is a both are numbers, so there is no unit for it. Right? Now coming to the next question. What can be concluded from the given figure? So there is a slight correction here. You change it to not coefficient of consolidation, you change it to compression index Cc. So which of the following has which of, from the figure is given, maybe I will just zoom it a bit. So what can be concluded from this figure about the compressibility?
Is it MCQ, sir?
Sir,
There can be multiple options also.
Okay.
soil 1 is less compressible than soil 2.
Is it? So how will we analyze this?
Is it option A and C, sir?
Is soil 1 less compressible or soil 1 more compressible?
Soil 1. No.
Soil 1 is the solid line. Soil 2 is the
Okay. Soil 1, I think, is more compressible.
how will we
Initial void ratio is high.
yes, so how obviously we compare it with the slope, right?
Yeah.
So here we take equal interval of sigma dash for both the cases, all right? So this is the interval which we consider for both the soils. Understood?
Yes, sir.
Now this is the initial void ratio for soil 2. and this is the initial void ratio, final void ratio for soil 2, right? Now this is the initial void ratio for soil 1, and this is the final void ratio for soil 1. Is it clear?
Yes, sir.
Let me draw in a different color. So for the same increment of stresses, what happens to soil 1?
Delta E is more.
E of 1 is greater than delta E of 2, right?
Yes, sir.
Hence, which is more compressible?
Soil 1 is more compressible.
Soil 1 is more compressible. Obviously, option B is right. And since delta E is, that is, since delta E greater than delta E2, what happens to CC?
Numerator is more.
Because denominator is remaining constant,
Same.
right? So CC of 1 is greater than CC of 2. So the right option is option B and option C. Any doubts?
No, sir. At higher stresses, we cannot check, na, sir, because lower stress only it is very clear.
Yeah. Higher stress, obviously, it will reach it to its ECR value,
Okay.
critical
Void ratio.
void ratio. Yeah.
Mhm.
So higher stresses also, and yeah, here this is only this is the initial behavior. So if the compressibility index of a soil is 1.26, what will be its liquid limit? There are two common empirical relations.
Twenty-four, sir, percentage.
Yeah.
24%.
So CC, there are two relations,
009.
0.009
Liquid limit minus
liquid
10.
liquid limit minus 10, which is given by
Terzaghi and Beck.
Terzaghi. And second relation is 0.007
7 into liquid.
into WL minus 10, which is given by Skempton, right? So based on this relation, what is the value?
24, I think.
0.26 divided by 0.009.
Okay, 50 here.
How much you are getting?
150, sir. 150.
Yeah, this will be WL will be 150%, and this one
190.
190. So obviously you can see compressibility index is fairly higher. So that is obviously getting reflected in liquid limit. So usually this will be in less than 1, 0.1 or 0.01 ranges. So since it is extremely high values, so we are getting extremely high liquid limit. So obviously it should be around bentonite or similar
Highly compressible, sir.
highly compressible soils.
If you don't mention the author, which formula we have to pick up, sir? We assume that.
Usually we use Skemptons. Yeah.
Because it's clays.
Yeah, this one we use.
Mm-hmm. But in competitive exam, if you don't mention author, how to pick up? That's my.
You can usually they will mention it. Otherwise, usually Skempton is being used now.
But some author, somewhere they mentioned that Terzagistri is used for undisturbed soil, which we use for consolidation.
Uh,
Second one is for remolded clays, na sir?
yeah.
Therefore, again, author, if you forget author,
Yeah.
generally we are going to use always undisturbed soils only na, for consolidation.
Undisturbed soils, but if you that is laboratory tests usually uh, uh, preparing UDS in consolidation rings, obviously the sample will get slightly disturbed.
Mhm.
So in that cases, uh, as you said, Terzaghis theory, that is Terzaghis relation is valid for undisturbed, whereas Kempton is for remolded.
Mm.
So uh, if they don't mention, you can assume it as remolded and you can apply Kempton's one.
Okay, sir, understood.
Coming to the next question, variation of pore water pressures and uh, pore water pressure, effective stress and total stress with time for the load increment step in a consolidation test is depicted in the figure. Match their variation suitably. So for a particular increment of load, they they have plotted the variation in pore water pressure, effective stress and total stress. So we have to identify which curve corresponds to uh, which property. Any idea?
Uh, C is for total stress, sir.
So C is a solid line.
For
So
total stress.
it is, we know obviously total stress will not change during the entire process. So C is for total stress.
And B is for excess pore pressure.
Yeah. So B is the dotted line with the extended dotted line. Uh, it is not a dotted line, it is a
Broken
discontinuous
line,
line,
broken line.
broken lines.
Hmm.
So it is obviously the variation in excess pore pressure. So you can write it as excess pore pressure.
And A is
Usually,
for effective stress.
yeah, because usually new learners tends to confuse with during consolidation. They think that pore water pressure itself on an entirety becomes zero, so which is not the case. So always try to uh, when we are discussing consolidation, always we try to use it completely as excess pore water pressure.
Hmm.
So obviously B is for effect. Sorry, V is for excess pore pressures, excess pore water pressures, and A is for effective stress. So it tends to zero and it tends to the total stress value. Right.
Yes, sir.
Now coming to the next question, the following results were obtained from an one-dimensional consolidation test. From an one-dimensional consolidation test, what will be the Voigt's ratio for a 1000 kPa stress? What will be the Voigt's ratio for a 1000 kPa stress, vertical stress? So here the parameter which relates entire thing is Cc. Cc is delta E by log of sigma 2 dash by sigma 1 dash. If we do it 1.2 minus 0.95 divided by log of 600 by 200. All right. How much we are getting? This will be 1.2, 0.15, 0.25 divided by log 3. How much we are getting?
0.523.
0.52.
4, sir. 5 to 4.
5 to 4. Right. Now we need to know the 1000 kPa stress for which Cc remains constant. Delta E varies from 0.95 minus E final divided by log of 1000 by 600, which comes to 0.524 into log of 5 by 3 equal to 0.95 minus EF. How much we are getting?
0.834.
Yeah. So EF will be 0.83. Alright. So logically we are getting lesser Voigt's ratio than the given Voigt's ratio. Any doubts?
No, sir. Thank you.
Fine, right?
Mm.
So coming to the next question. A clay soil of clay soil layer of 3 meters with a coefficient of volume compressibility of 0.81 centimeter square per kg and a change in applied pressure of 0.25 kg per centimeter square, what will be the settlement? How will we calculate it? So we know MV. MV is defined as delta H by H into delta sigma V dash, right? So we know that MV is 0.18, delta H we need to find H is 3 meters, everything is in centimeters, so we convert it into 300 and delta.
No need of 300, sir. Answer is asked in meters.
However, but the entire units is in centimeter, right? Eventually you can convert finally.
MV and delta sigma both units get cancelled, sir. H value is exactly required answer.
Yeah, fine. Then it's fine.
Yes, sir.
3 and 0.25. So delta H 0.18 into 3 into 0.25.
Option B, sir. 0.135.
Yeah, so it is 0.135 meters. Now coming to the next question. For a over-consolidated clay deposit, the pre-consolidation pressure is 125 kilonewton per meter square and the overburden pressure is 75 kilonewton per meter square. The OCR of the deposit is. How much?
Is it a present overburden, sir? Second
Yeah,
statement?
yeah.
Okay. It is 1.66.
Yeah. So OCR is defined as past pressure by present. So 125 by 75. Which will obviously give this is 5 by 3. 1.66. Now coming to the next question. So the settlement analysis for a clay layer draining from top and bottom shows a settlement of 2.5 centimeters in 4 years and an ultimate settlement of 15 centimeters. However, detailed subsurface investigation that there is no drainage at bottom. The ultimate settlement in this condition will be. Any idea how to calculate?
Ultimate settlement is a constant, sir, no change.
Yeah. So this is the ultimate settlement will not change. That is the delta H will not change. So it will be 15 centimeters. In this case, ultimate settlement also will be 15 centimeters. So there will be no change. Fine. But the rate of achieving those will be changing based on the drainage conditions. All right. So
Yes,
coming
sir.
to
Time
the,
changes.
yeah, time changes.
Hmm.
So time rate will be covered in the next week. So we are covering only. Right. During a consolidation test, a sample of fully saturated clay 3 centimeter thick is consolidated under a pressure increment of 200 kPa. When equilibrium is reached, the sample thickness is reduced to 2.6 centimeters. The pressure is then removed and the sample is allowed to expand and absorb water. The final thickness is observed as 2.8 centimeter and the final moisture content is determined as 24.9%. The specific gravity of the soil solids is 2.7. Find the voids ratio of the sample before and after consolidation. Now coming, how will we calculate it? Uh, so the initial thickness is 3 centimeters. And now we know the final conditions. So final moisture content is 24.9%. Final G is 2.7. All right. Now with this, the saturation is going to be 100%, both before and after the test. So we know Se is equal to Wg. S is going to 1. E will be 0.249 into 2.7. How much you are getting?
0.6723.
Point
0.6723.
67. Let, void ratio will be limited to 2 decimals, so you
Okay.
can round it off.
Okay.
So 0.67. This is the final voids ratio, right?
Mm.
So now the thickness, here we have to find what is the change in how to. So delta H by H is equal to delta E by 1 plus E naught, right? E naught here for this condition we are back calculating it, right? So for this delta H is going to be 2.8 minus 2.6 divided by 2.6 is equal to delta E. This is initial, final minus initial, right? So final will be 0.67 minus E divided by 1 plus 0.67. How much we are getting? Sorry. This will be E only. Initial voids ratio, right? So this will be E. How much we are getting? E value?
Is it 0.552, sir? 55?
So this will be, obviously it should be lesser than 0.67. How much we are getting? 0.55,
55, sir.
right?
Yeah, yes.
So this is this is at the end of consolidation. All right. Now we have to find what is the initial. We know what is after consolidation. We know what is the void ratio, and we need to find now the voids ratio before consolidation. For that, we know what is the change in thickness that the sample has undergone during consolidation, which is 2.8 minus, sorry,
Sir, can you draw the diagram, sir, so that it will be easier to
yeah,
understand?
yeah, yeah. So this is,
First,
so this is initial condition,
okay.
which is 3 centimeters. All right.
Yes, sir.
Now it is reducing it to
2 point,
2.6.
yes.
This is 2.6. Now this is, now we are removing the load.
Hmm.
Now again it is increasing to
2.8.
2.8 centimeters. Understood? Now
Yes,
here its voids ratio is
0.67.
0.67. Now it is, this point it will be at its lowest void ratio, right?
Yes, sir.
So that is obviously we are getting lower void ratio than 0.67. Let it be 0.55, whatever we are getting, right? We can cross check it afterwards. Now we need to back calculate between this from here to here, right? So what is the total change undergone? This is 3 minus 2.6 by 3 is equal to, void ratio is 0.55 final minus initial divided by 1 plus E naught. How much you are getting now? E naught is
0.36. 37.
0.37. It should be higher.
It should be higher. 1 minute.
Getting properly or not? We have done anyway.
It's the same I am getting.
0.55 is the final value. 3 minus 2.6. Will be 0.8 minus 2.6. Getting final value, we are getting as 0.67. This is fine. Here it is E. This is the initial value. This is the initial thickness.
Write the formula, sir, that will be easier to catch the mistake.
Yeah, yeah.
Directly you are substituting numerical.
So this is the thing which we use. So delta H is
Delta H first case it should be negativeness, huh? Because expansion to compression. We are comparing the
yeah,
last
final
expansion.
minus initial by initial, right? So it should be 2.6 minus 2.8 by 2.8 is equal to final voids ratio 0.67 minus initial void ratio E by 1 plus E. Yeah. This is where we have made it. But will we get proper values, or then in this case, it is an
Sir, first case
hmm.
2.8 minus 2.6 by 2.8 now.
Yeah, so this is fine. This value is right.
Oh, 0.55 white ratio is correct only, na?
Yeah, this is right.
Uh-huh.
So this is logically right, and the values are also right. I have cross-checked with my calculations. And here, if we see this, it should be 3 point. This is H final minus H initial by H initial equal to E final minus E initial by 1 plus E initial, right? So HF here it will be 2.6 minus 3 by 3 is equal to E final will be 0.55 minus E initial by 1 plus E initial. Now you can calculate, I think. Now you will get the proper values. This is the mistake we are doing. 2.6 minus 3 divided by 3. So we are getting EI will be 0.79. We are able to get this value.
1 minute, sir, please. Hold on.
You are getting the values?
1 second, sir. Last steps. Yes, sir. 0.78 I got.
Yeah. Right. So that is before consolidation, void ratio is 0.79. After consolidation, the void ratio is 0.55. All right.
Yes, sir.
So now coming to the next question. A clay stratum, which is what to, which is NC. NC clay stratum 7 meter thick is located at a depth 12 meter below ground level. The natural moisture content of the clay is 40.5% and its liquid limit is 48%. Specific gravity is 2.76. The water table is located at a depth 5 meter below ground level. A layer of sand is above clay stratum whose submerged unit weight is 11 kilonewton per meter cube and 18 kilonewton per meter cube above the ground level. The average increase in pressure at the center of the clay layer is 120 kPa due to weight of the building. Compute the expected settlement. Now we will translate this to the diagram. So this is the ground level. Alright. Now there is a clay stratum of 7 meter which lies at 12 meter. So that means it has a 12 meter of sand above it. 12 meter. This is 7 meters. Right? Now here another thing is they have given that water table is located at a depth of 5 meter below ground level. So this is the groundwater table. So this is at a depth of, let me do this, 5 meters, 7 meters. Alright. Now this is sand where this is this will be 1811. Submerged unit weight is gamma B is 11 kilonewton per meter cube. Here gamma is 18 kilonewton per meter cube.
What is gamma W, sir?
Gamma W you can take it as 10.
Okay.
Okay. Now here they have given G is 2.76 and water content is 40.5%. Right. Now delta sigma dash is 120 kPa. Alright. Now what we need is delta H. Right. Now what is the relation for delta H? Delta H is equal to Cc by 1 plus E naught into H into log 10 of sigma naught dash plus delta sigma divided by sigma naught dash, right? Now major thing what we need is h we know, which is the we always calculate at the middle of the layer, right? So 3.5 this is 3.5 meters of clay layer, but the entire thickness is 7 meters. The stress which we calculate corresponds to 3.5 meters. All right. Now we need to find sigma dash, sigma naught dash, E naught and CC. So CC is easier. So since it is a natural deposit, we use Terzaghi's value. How much we are getting?
0.342.
0.342,
2.
and E naught is
1.1178.
SE is equal to W into G.
E
S is
point
1. E is equal
1.12.
to 0.405 into 2.76. How much?
1.12. 1.12.
1.12. Alright. So CC we got, 1 plus E naught we got. We need to calculate sigma dash. So sigma naught dash is equal to 18 into 5. We need to find gamma also.
Yeah, gamma for clay. Gamma submerged for clay.
Gamma submerged or gamma saturated also. Gamma saturated, and you can you can separate it from separate gamma W from it, right? So gamma sat will be gamma W into G plus E divided by 1 plus E, right? 10 into 2.76 plus 1.12 divided by 2.12. Much you are getting? 2.76 plus 1.12 into 10 divided by 2.12.
0.3.
18.3 kilonewton per meter cube. Gamma submerged will be 8.3. So this will be 18.5, 18 into 5 plus 11 into 7 plus 8.3 into 3.5. This will be 90 plus 77 plus 8.3 into 3.5. This will be 29.05, which will come to plus 90 plus 77, come to 196.05 kilopascal. You are getting this value?
Yes, sir.
Now substitute all the values in the above equation. Delta H is equal to CC is 0.342 divided by 2.12 into 7 into log of 196.05 plus 120 divided by 196.05. How much settlement we are getting?
0.234.
meters, right?
Yes, sir.
0.234
234.
meters. That is 23.4 centimeters. Almost 10 inches. Fine. So now coming to the next question. The soil profile is shown in figure. So if a UDL of 100 kPa is applied at the ground surface, so this is the UDL. Hundred kPa is applied at the ground surface. What is the settlement of the clay layer caused by primary consolidation? If the clay is normally consolidated, pre-consolidation pressure is 190 kPa and 170 kPa respectively. So there are two cases where 190 kPa and 170 kPa of pre-consolidation pressure. All right. Now this is the clay layer. This is the sand layer. Sand and clay. Right. Now this we can consider, we can make an assumption that this load, this increment of load is common because this is a surcharge load, right? So now we have to same values. First clay is NC, so we need to find CC of clay. So how will we calculate? Since it is a natural deposit, we use Terzaghi's theory 0.009 into WL minus 10. How much we are getting? 0.27, I think, right?
27, yes, sir. So what is the thickness of the layers, sir?
Okay, just a minute. 4 meters. This is 2 meters, 4 meters, and 4 meters.
Okay.
All right. So next is we need to find, we know the E value here. We need to find sigma dash, sigma naught dash, which will be 14 into 2 plus 18 minus 10 into 4 plus 19 minus 10 into 2. $28 plus 8 into 4, 32 plus 18. 32 plus 28, 60, it will be 78. Right?
Yes, sir.
In kPa. Now delta sigma will be 100 kPa. So now since it is NC, we know that delta H will be equal to Cc by 1 plus E naught H into log 10 sigma naught dash plus delta sigma dash by sigma naught dash. Right? So this will be 0.27 by 1 plus 0.8 into 4 into log 10 of 178 by 78. How much we are getting?
0.214
It is 21.4 centimeters,
centimeters.
right?
Yes,
So
sir.
first case is done. Now coming to the second case, pre-consolidation pressure is 190 kPa. So here we need to analyze this situation. So sigma naught dash plus delta sigma dash is equal to 178, right? Which is less than 190. All right.
Yes, sir.
So this is a completely over consolidated
Oh, sorry.
soil, right? So here then we need to use, instead of Cc, we need to use Cs, which is 1/6 of Cc. So 0.27 by 6. How much you are getting? 0.0.
36.
No, it should be greater than 4. 0.04. 0.27 divided by 6. 0.0
You are asking what is CS, huh?
Cs, yes.
CS is 0.045.
45. And now we can substitute this in the same equation. Delta H will be Cs by 1 plus E naught into H into log of 178 by 78. Right. Now what will be the value here?
3.6 centimeter.
3.6 centimeters, right?
Yes, sir.
Fine. Now coming to the third case.
Sir, a small interruption here.
Yeah.
Since the formula difference is only CS and CC,
Yeah.
I cross check also with the answer directly. The 21.4 what we got the settlement for NCC.
Mm-hmm.
If you divide directly that by 6 also we get the same answer, no sir?
Yeah, that you will be getting. Yes.
We can do no sir like that also?
Yeah. You can
Competitive
do.
exams?
Yeah.
Okay, okay.
Now next case is uh
Reconsolidation pressure is 170, I think, next case.
yeah, pre-consolidation pressure is 170. So this is sigma naught dash plus delta sigma dash is greater than 170, right? So in this case, it should be the entire relation will be splitted, right? So it will be Cc by 1 plus E naught into H log of sigma dash plus, sorry, it will be sigma pre-consolidation pressure by sigma C dash plus Cs by 1 plus E naught into H into log of the remaining value, which will be sigma naught dash plus delta sigma dash by sigma p dash, right? So it will be 0.27 by 1.8 into 4, or you can take this 4 to this side, delta H by 4 for simplicity, log of 170 by 78 plus 0.045 by 1 plus E naught is 1.8 log of 178 by 170. How much we are getting?
Sir, is it initial portion is C or CS? Sir?
This will be CC. This will be CS. This is the over consolidated portion.
Uh,
Wait, just a minute.
yeah,
Yeah, this will be CS actually.
CS, sir. That's why
Yeah,
I'm
this will be
looking.
CS. This will be because this is the over consolidated portion. This is the
Yeah, yes, sir.
INC portion.
Mhm.
So you just make a correction here. This will be to 0.27.
7. This will be 0.045.
And this will be 0.045. Thank you.
Yeah, then answer is 4.53 centimeter. H you have not written, sir.
H is here. I have taken it to denominator.
Okay, outside. Okay.
Yeah. How much you are getting?
Delta H is 4.53 centimeter.
4.53.
Yes, sir.
Just let me check with my answers. Yeah, fine. So there is one problem which is left over. We'll be solving it in next week. So with this, the present for the today's session comes to an end. So this slides and video will be uploaded in the public forum, and you can access these videos in the from your account, NPTEL account. So, and these classes most probably next week will be the last session because the course gets completed next week, I guess. So
Yes, sir.
the next week we'll be completing this session, and so this session will be conducted from 5 p.m. to 7 p.m. on Saturdays. So let's meet next week. Thank you.
Sir,
Yeah.
do you have a time, sir? Any 1 minute? Or,
Yeah, please.
can you go to next slide, sir? Next slide means blank slide, a small doubt.
Yeah.
It's about first question only.
Yeah.
Regarding that pore pressure and hydrodynamic pressure comparison.
Yeah.
I want to, through small example, I want to clarify here.
Yeah.
Just draw one ground level and water table on the ground level.
Yeah.
Water table also on the ground level.
Okay, fine.
When soil is completely submerged clay.
You are having a single layer.
Yeah, it's okay, sir. No problem.
Yeah.
For example, at the bottom, whatever you have drawn the line, we assume that is a 5-meter depth from the ground surface.
Fine.
Okay, sir?
Yeah.
Now, at the bottom of the ground, the pore water pressure is 5 into gamma W, 10 kPa.
Yeah.
That is called static pressure,
Yes,
hydrostatic
yes,
pressure.
yes.
Now, for example, if you apply a building load of 100 kPa on the top,
Fine.
and if you insert a piezometer on the
Hmm.
same place, at the
Yes.
bottom you can give some name as a point P.
Hmm.
Okay, there you can give a point P.
Yeah.
Then if you insert a piezometer
Yeah.
above the ground surface, it will raise by the building pressure is 100 kPa.
Yeah.
You can write, sir, building pressure also 100 kPa remarks.
100 kPa. Fine.
That means hydrodynamic pressure is also 100 kPa.
Yeah. Because
That
soil
is,
is saturated.
yeah, initially it is a pore water pressure, the hydrodynamic pressure is taking the entire load.
Yeah.
Therefore, above the ground surface, U bar is going to be 10 meters of the height. Is it correct, sir?
10 meters of the height. No, I'm not getting your point. Above the ground, you
You
are
can
saying.
insert, sir. You can insert the piezometer up to point P.
Okay,
From the
fine.
point P,
Yeah.
just insert the piezometer.
Yeah.
Yeah. Now, if you try to see above the ground level,
Yeah.
the height of the water raise is equivalent to above the ground level.
It will be 10, na?
Yeah, just write it, sir. That's what I'm asking.
Yeah,
Just
yeah. 10.
that is equivalent to height of the water raise is equivalent to 10 meters.
10 meters, yes.
Now the question is,
Yeah.
if you make a U bar,
Okay.
U bar is 100 kPa, correct, sir?
Yeah.
And U is going to be 10 plus 5 into 10,
Yeah.
150 kPa.
Yeah. Yeah.
Right, sir. And side by you can write U bar is equal to 100 kPa. U is
Excess pore
equal to
water pressure is going to be 100
100
kPa.
kPa, equivalent to applied load.
And initial will be
10 plus 5 into,
no,
is
no.
it correct? No?
Excess is 100. Total will be,
Uh,
sorry,
U is equal, pore water pressure is equal to
total will be 150.
150. Is it clear, sir?
Yeah. Initial
Yeah,
will be
yeah.
50.
Yeah.
Yeah.
Now, this is what my question is. For example, at
Mm-hmm.
the end of the consolidation,
Yeah.
what is the U bar and U total?
U bar will be 0.
Zero. That is clear. That's
Yeah.
what your first question today's session.
Yeah. Yeah.
What is going to be UT?
UT will
Is it 50 or
be,
less than 50 or 0?
no, UT will not be 0.
Yeah, then it should be less than 50, na, sir? Or,
It will be, ideally it should be equal to 50, but the settlement is also happening.
uh,
So practically it should be a little bit greater than 50.
okay, because of what is suction or what, sir? Or
Not suction, due to the
100%
realignment
consolidation
of
may not take.
planes, permeability is also getting reduced.
Okay.
So actually the major assumption of Terzaghis theory is that permeability
Hmm.
remains constant entirely.
Hmm.
But that will not be the case. But
Okay.
if you consider the settlement will be in the range of millimeters, right?
Yes, sir.
So that does not actually impact the pore pressure to much extent. So it will you can consider always it is reaching to a initial value.
Mm-hmm. So at the time is infinite, U bar is 0 and UI is going to be 50 only.
Yeah, yeah, 50 only.
UT and UI both are 50.
Yeah, yeah, yeah. Yes, yes.
Okay. And water table remains same or disappears, sir?
No, no, water table remains same.
Remains
The
same
soil
only.
will be completely saturated at
Saturation
any
only.
cost.
Okay,
Yeah, yeah,
okay, okay. That's all, sir. That's
yeah.
the same. Because about nobody talks about UI and UT in the consolidation chapter.
Yes, yes, yes.
The first
Actually,
question, we got a
what happens
confusion
is,
because of this.
yeah, yeah. What happens is that
Hmm.
this consolidation entirely is divided into two.
Hmm.
So one is compression aspects, which we only concentrate on calculation of settlements,
Okay,
and second part is time rate.
okay, okay.
So that is where this entire confusion takes place.
Mm-hmm.
So that is taught in such a way that it becomes easier for teaching.
Okay.
So, but as far as if you want to understand the concept entirely, so you have to correlate both the aspects and then we have to study.
Is it any, have you studied, sir, any book about U initial, U total, how it is
See,
going to?
usually what happens is that you can, uh, if you can draw the pore pressure distribution,
Mhm.
excess pore pressure distributions you can find in textbooks.
Yeah, that is clear, sir. That's clear. I don't have any doubt about excess hydrostatic pressure.
No, that you can find that variation.
Okay.
With that, you can understand what happens to initial also. So it will be a parabolic curve.
Uh,
So what happens to that? You can find in two very several textbooks which has been referred in the course also.
yeah, they mention, they show that it is a straight line. At the end of t is equal to infinite, it is a straight line. Beginning
Yeah,
also, it is a straight line.
yeah. So that means it is coming back to initial pore water only, pore water pressure only.
Yes, sir. I understood. That's what I am telling. U bar is clear in all the books, sir.
Yeah.
Only about U total and U initial.
Yes.
I
Ideally,
didn't.
we consider it it is reaching to initial.
Mm-hmm.
Yeah.
Okay. Right, sir. Thank you very much.
Yeah. Fine.
Good night, sir.